In this video, we will see how we can use a Runge-Kutta method of fourth order to solve simultaneous differential equations of the type dy by dx equals f1 of x comma y comma z and dz by dx equals f2 of x comma y comma z, where this x is independent variable and this y and this z, these are dependent variables, which means the values of x will be known and we will have to find the values of y and z. As usual, we will use the initial conditions y equals y0 and z equals z0 when x is given to be x0. The initial conditions will be x0 comma y0 comma z0 and the resulting increments in y will be k and that in z will be L. By applying Runge-Kutta method, we will find k1, k2, k3 and k4, from which we will find k, and from the values of L1, L2, L3 and L4 we will find the value of L. Now the approximate values of y1 and z1 will be y1 equals this y0 plus this k and z1 will be this z0 plus this L. So this is the overall procedure of solving simultaneous differential equations by using Runge-Kutta method of fourth order. Hello friends, you are watching YouTube channel Number Collage. This channel features easy to understand concept videos on mathematics. We will solve simultaneous differential equations dy by dx equals x plus z and dz by dx equals x minus y square with initial conditions x0 equals 0, y0 equals 2 and z0 equals 1, and the step width h is given as 0.1. Now here we are given f1 of x comma y comma z equals this x plus z and f2 of x comma y comma z is this x minus y square, and these initial conditions and this step width. First we will find values of k and L. For that, first we will find k1 by Runge-Kutta method. K1 is h times f1 x0 comma y0 comma z0 equals 0.1 multiplied by 0 plus 1, that will be 0.1. Then L1 will be h times f2 of x0 comma y0 comma z0, that will be 0.1 times 0 minus 2 square, so that will be minus 0.4. Next we will find k2, which is h times f1 of x0 plus h by 2 comma y0 plus this k1 upon 2 z0 plus L1 upon 2, so that will be 0.1 multiplied by 0 plus h by 2, that is 0.1 by 2, 0.05 z0, which is 1, plus minus 0.4 upon 2, that will be minus 0.2, so that will be 0.085. Next L2, that will be h of f2 x0 plus h by 2 comma y0 plus k1 upon 2 comma z0 plus L1 upon 2, so that will be equal to 0.1 multiplied by 0 plus h by 2 0.05 minus y0, which is 2, plus k1 upon 2, that is 0.1 upon 2, 0.05 whole square, that gives minus 0.41525. Next we will calculate k3, which is h times f1 into x0 plus h by 2, comma y0 plus k2 upon 2, comma z0 plus L2 upon 2. So that will be equal to 0.1 multiplied by 0 plus 0.05, that will be 0.05 plus z0, which is 1, plus L2 upon 2, that is minus 0.41525 upon 2, which will be minus 0.20762, that will be 0.084238. Next we will calculate L3, which will be h times f2 of x0 plus h by 2, comma y0 plus k2 by 2, comma z0 plus L2 by 2. So that will be 0.1 multiplied by 0.05 minus 2.0425 whole square, which will be minus 0.4122. Now K4 will be h times f1 of x0 plus h, comma y0 plus k3, comma z0 plus L3. So that will be 0.1 multiplied by x0 plus h will be 0.1 plus z0 plus L3 will be 0.5878, that will work out 0.06878. Then L4 will be h times f2 of x0 plus h, comma y0 plus k3, comma z0 plus L3. So that will be 0.1 multiplied by x0 plus h will be 0.1 minus y0 plus k3 will be 2.084238 whole square. So that will work out minus 0.4244. Let us write the values that we have found out. K1 equals 0.1, K2 equals 0.085, K3 equals 0.084238, and K4 we have just found out. So from these four values, K will be 1/6 of K1 plus 2 K2 plus 2 K3 plus K4, that will be 1/6 of 0.1 plus 2 times 0.085 plus 2 times 0.084238 plus 0.06878. So K will work out 0.0845. Next we will write values of L1 equals minus 0.4, L2 equals minus 0.41525, L3 equals minus 0.4122, and L4 we have just found out. So from these four values we calculate L equals 1/6 of L1 plus 2 L2 plus 2 L3 plus L4, which will be 1/6 of minus 0.4 plus 2 times minus 0.41525 plus 2 times minus 0.4122 plus L4, which is minus 0.4244. So L works out to be 0.4132. Okay, now that we have found out K and L, we write the solution of the given simultaneous differential equations for x equals 0.3 as y1 equals y0 plus k, that will be 2 plus 0.0845. So that gives y1 equals 2.0845 and z1 equals z0 plus L, that will be 1 minus 0.4132, that will be z1 equals 0.5868. So this is the solution of given simultaneous differential equations. We will solve simultaneous differential equations dy by dx equals xz plus 1 and dz by dx equals minus xy by using Runge-Kutta method for x equals 0.3 and the initial conditions given are y0 equals 0, z0 equals 1 when x0 is 0. We have the first differential equation f1 of x comma y comma z equals this xz plus 1, and the second differential equation is f2 of x comma y comma z, which is this minus xy. We will take step width h equals 0.3. First we will find the values of k1, k2, k3 and k4 for finding the value of k. So first k1 equals h times f1 of x0 comma y0 comma z0. So that will be 0.3 for h multiplied by x0 is 0 multiplied by y, which is 1 plus 1, so that will be 0.3. Then L1 is h times f2 of x0 comma y0 comma z0, that will be 0.3 for h multiplied by minus x0 is 0 multiplied by y0 is also 0, so that will be 0. Then k2 will be h times f1 of x0 plus h by 2 comma y0 plus k1 upon 2 comma z0 plus L1 upon 2, so that will be 0.3 multiplied by x0 plus h by 2 will be 0 plus 0.3 upon 2, 0.15 multiplied by z0 is 1 plus this 1, that will be 0.345. Next L2 will be h times f2 of x0 plus h by 2 comma y0 plus k1 upon 2 comma z0 plus L1 upon 2, so that will be 0.3 multiplied by minus x0 plus h by 2, that will be 0 plus 0.15, so minus 0.15 multiplied by y0 plus k1 upon 2, that will also be 0 plus 0.15, that is 0.15, which will be minus 0.00675. For reference, we write f1 of x comma y comma z equals xz plus 1. Then f2 of x comma y comma z equals minus xy, and the values of k2 0.345 and L2 minus 0.00675, and we will now calculate k3, which is h times f1 of x0 plus h by 2 comma y0 plus k2 by 2 comma z0 plus this L2 by 2, that will be 0.3 multiplied by x0 plus h by 2 will be 0 plus 0.15, that will be 0.15 multiplied by z0 plus L2 upon 2 will be z0 is 1 plus L2 upon 2 will be minus 0.00675 upon 2 plus this one will work out 0.34485. Next L3 will be h times f2 of x0 plus h by 2 comma y0 plus k2 upon 2 comma z0 plus L2 upon 2, so that will be 0.3 multiplied by this minus of x0 plus h by 2, that is 0 plus 0.3 upon 2, 0.15 multiplied by y0 plus k2 upon 2 will be 0 plus minus 0.00675 upon 2, that gives minus 0.007762. Next we will find K4, that will be h times f1 of x0 plus h, comma y0 plus k3, comma z0 plus l3. So that will be 0.3 multiplied by x0 plus h will be 0 plus zero point 0.3, that is 0.3 multiplied by z0 plus l3, that will be 1 plus minus of 0.007762 plus this one gives K4 equals 0.3893. L4 will be h times f2 of x0 plus h, comma y0 plus k3, comma z0 plus l3. So that will be 0.3 multiplied by minus x0 plus h will be minus 0 plus zero point 0.3, that is 0.3 multiplied by y0 plus k3 will be 0 plus k3, that is 0.34485. That gives L4 equals minus 0.03104. We have found K1 equals 0.3, K2 equals 0.345, K3 equals 0.34485 and K4 equals 0.3893. So from these values we will find K equals 1 upon 6 multiplied by K1 plus 2K2 plus 2K3 plus K4, that will be 1 upon 6 multiplied by 0.3 plus 2 multiplied by 0.345 plus 2 multiplied by 0.34485 plus K4, which is 0.3893. So K works out to be 0.344. Next we will write down the values of L1, which is 0, L2 is minus 0.00675, L3 equals minus 0.007762 and L4 minus 0.03104. Now from these values we will find L equals 1/6 of L1 plus 2L2 plus 2L3 plus L4, that will be 1/6 of 0 plus 2 multiplied by minus 0.00675 plus 2 times multiplied by minus 0.00762 plus minus 0.03104. So L works out to be 0.98999. Now we will write the values of y1, which is y0 plus k, that equals 0 plus this k 0.34483, that gives y1 equals 0.34483 and z1 is z0 plus l, that will be 1 plus this l, which is 0.98999, that gives z1 equals 1.98999. Our solution of the simultaneous differential equations is for x equals 0.3. We have found y1 and z1 by Runge-Kutta method. We have found k1 equals 0.3, k2 equals 0.345, k3 equals 0.34485 and k4 equals 0.3893. So from these values we will find k equals 1 upon 6 multiplied by k1 plus 2k2 plus 2k3 plus k4, that will be 1 upon 6 multiplied by 0.3 plus 2 multiplied by 0.345 plus 2 multiplied by 0.34485 plus k4, which is 0.3893. So k works out to be 344. Next we will write down the values of L1, which is 0, L2 is minus 0.00675, L3 equals minus 0.007762, and L4 minus 0.03104. Now from these values we will find L equals 1/6 of L1 plus 2 L2 plus 2 L3 plus L4, that will be 1/6 of 0 plus 2 multiplied by minus 0.00675 plus 2 times multiplied by minus 0.007762 plus minus 0.03104. So L works out to be 0.98999. Now we will write the values of y1, which is y0 plus k, that equals 0 plus this k 0.34483, that gives y1 equals 0.34483, and z1 is z0 plus L, that will be 1 plus this L, which is 0.98999, that gives z1 equals 1.98999. Our solution of the simultaneous differential equations is for x equals 0.3. We have found y1 and z1 by Runge-Kutta method. If you like this video, please share this to your classmates. Don't forget to subscribe this channel. See you in the next video. Until then, keep watching Number Collage. Thank you.